Hello and welcome to Maths Academy. I am Noor Alam. I am extremely happy with you with this video. Now today we are going to learn something about the straight line and give the name heading as CDF concept definitions and formula. In this video we are not going to prove any results. We are not going to discuss any result in great details or any formula. Just we summarize the formula just as it is summary. When we are going to the details video of the straight line, in that cases, in that videos you are getting all the informations in fully and descriptions you are getting there. So now without wasting our times, we are going to start the summary of the formulas of the straight line. Now the first formula says that if the straight line, if the inclination of a line is theta, you know about what is theta. Theta is the angle made by the straight line with the positive direction of x-axis and measured in the anti-clockwise direction. So if the theta is like that, which is known as the angle of inclination, and theta is not equal to pi by 2, then we say that tan theta is the what? Tan theta is the slope of the line, or you can say that gradient. Now the slope, this word slope is equal to the gradient. Either you say that it is the gradient, or you can say that it is the slope of the line. And we already discussed the point 2, that is the angle made by the line with the positive direction of x-axis and measured in anti-clockwise direction. This is the angle theta. So if you take the angle like this one is the theta. Okay, now when we are going to find out the slope of the line when the 2 points are given, then we use this formula y2 minus y1 by x2 minus x1, or you can say that y1 minus y2 divided by x2 minus y1 minus y2 divided by x1 minus x2. Okay, now so this will be instead of y2 you should write y1 first, y1 minus y2, then it should be x1 minus x2. That means I want to say that the difference of the y coordinate by difference of the x coordinate. If you starting with y1, below will be the x1. If you starting with y2, the below should be the x2. And there are different form of the straight lines, we know that. Now if you know that any 1 degree equation of the two variables, any 1 degree equation of the two variable, here the degree of the term is 1, here is also 1, so therefore the variable are x and y. So any equation in the 1 degree with the two variables is generally gives the straight line in a plane. So this is known as the general form of the line. And if your line passing through the one point x1 y1, then how can we find the equation of the line? We take another point as any arbitrary point is x and y, then we calculate the slope y minus y1 by x2 minus x1, which is equal to the slope. So therefore m we can write as y2 minus y1, or here our y2 is y only, so we can write m is equal to y minus y1 by x minus x1, and after cross multiply you will get this equation, which is known as point slope form. If your line passing through the 2 points, one is x1 y1 and another is the x2 y2, then very easily you can calculate the slope of the line by calculating y2 minus y1 by x2 minus x1, which is the slope. And since the slope is known and the line passing through the x1 y1, we can easily write y minus y1 is equal to y2 minus y1 by x2 minus x1, x minus x1, that is 2-point form. If your line suppose having the here angle theta, and you know that it cuts the y-axis at the point 0 comma c, so one point is known and here the angle is known to you. So therefore we take any arbitrary point on the line, one is 0 comma c, I am taking x comma y. So therefore y minus c by x minus 0 is nothing but the slope. So from here after cross multiplication you get y is equal to mx plus c. This is known as the slope point form. Now the double intercepted form is what? Here a and b both are non-zero. If your line cut both the axes at a certain point, suppose here which is away from the a unit from the origin, and here at the b point, here as the point 0 comma b, that means this length is b, this length is a. So intercept may be the positive negative, but the length of the intercept is always positive. So if you know that both the intercept, that is the x intercept and y intercept, then you can write x by x intercept plus y by y intercept is equal to 1. X by x intercept plus y by y intercept is equal to 1. This is known as 2-point form, double intercepted form. Now another form is which is known as the normal form. If your line is given like that, if your line is there and the distance of this line, perpendicular distance, is known as small p, and this perpendicular makes the angle alpha. Okay, now so one line is given and the distance from the origin to the line is given is small p, which is positive, and this small p, that means this perpendicular makes the angle alpha with the positive direction of x-axis, and the alpha is always lying between 2 pi to 0, and the line having the slope which is 0 to pi, the line having the slope which is always 0 to pi, this line having the slope which is 0 to pi, and this angle is alpha. Then we can write as x cos alpha plus y sin alpha is equal to p. P should be the positive and alpha lying between 0 to 2 pi, but pi alpha cannot be equal to 2 pi. Okay, now this is known as the normal form. It is not written here, it should be, you can write at your copy, it is the normal form. Okay, now sometime I have forgotten to mention due to the hurriness. Now coming to the find out the 7th point, which is known as the distance form, or you can say that the parametric form. So if your line is passing through some point x1 y1, and you know the angle is also given theta, so we can write as tan theta is equal to y2 minus y1 by x minus x1, or from here you can write as y minus y1 by cos theta, x minus x1 by cos theta, y minus y1 by sin theta is equal to r, and this is the parametric form. This r is what, suppose it is the line which is passing through the point x1 y1, and there is another point at a distance of r, either above or below, or either the right or left of the given point x1 y1 is here, this point x1 y1 is the fixed point. Your line is passing through the fixed point, you will take any arbitrary point xy which is away from r unit, so that's why we are getting this r we are getting. So if you do the cross multiplication, it will be x is equal to x1 plus r cos theta, y is equal to y1 plus r sin theta, and this point has the capability to generate all the points on this straight line. That's why it is known as the parametric form. Now we are going to illustrate how the angle, what is the value of this angle between the two lines. So we are taking this angle is the theta 1. Suppose we are going to calculate the angle between the two lines. So in this case what we are doing, we take in this way the diagram like this one, this is our theta, and this is theta 1, this is theta 2. So you know the this will be the theta 2, then you know that theta plus theta 2 equal to theta 1. Okay now, so again this is our x-axis, these and these are given, this angle if you consider theta 1, this angle theta 2, this angle is theta, angle between the two lines, so theta will be equal to theta 1 minus theta 2 because exterior angle is equal to sum of the opposite interior angle. You know this property from the class 8 book or from the elementary geometry. Now we are going to apply the tan from the both sides. So it will be tan theta, that is equal to tan theta 1 minus tan theta 2 divided by 1 plus tan theta 1 tan theta 2, and tan theta 1 is nothing but m1 and tan theta 2 is equal to m2. Now this is the formula by which we can calculate the angle between the two lines, and since mod is given, that means when you remove the mod you are getting the positive negative sign. So why we are getting the two types of angle? Because if this angle is theta which is acute, then this angle is theta 1 which must be the obtuse angle. So you can consider the acute as well as the opposite angle as well as the obtuse angle. So now what will happen if the numerator is 0? If the numerator is 0, then the tan theta is 0. Numerator is 0 means m1 m2 having the same value. That it is only possible when your lines are parallel. When your lines are parallel, then it is possible. Now if the lower part is 0, then the theta is 90 degree. That means it is only possible if your lines are perpendicular. If your lines are perpendicular, then we notice that the denominator of the tan theta becomes 0, that becomes the infinity. Okay, now next we are going to calculate the image of a point with respect to some line. Suppose this line is given whose equation is ax plus by plus c equal to 0. Here is the point x1 y1, and in the below the point is given which is hk, and this will be the image, hk will be the image of x1 y1. So here we can use the formula h minus x1 by a plus k minus y1 by b is equal to minus 2 into ax1 plus by1 plus c divided by hk plus b square. So this formula generates the image points. But if you are going to interested this is the x1 y1 point, and you are wants to take the foot of the perpendicular, you need to multiply this formula by by 2. You just without 2 if you write, you will get the same formula. Now coming to the formula number 17. Here we are going to calculate the distance of a point. Suppose this is a line which is given, and this is the point x1 y1 which is also given. Now this length you are going to calculate, this length, this is called the d small d. So now it will be x1 plus b1 plus c divided by root over a square plus b square. Distance of the point distance between the two parallel lines. If the two parallel lines are given, suppose this one and this one is parallel, so I am first calculating the distance of the distance of a line from the origin two lines are given. I'm calculating the distance of the line from the origin, then from the origin, and then I'm going to subtract this perpendicular distance, and we are getting the required distance. So here you have to do the difference of the constant with modulus sign divided by a square plus b square. Now this part should be the same. This part should be the same for the parallel line. All of you know about it. Any line parallel to the given line. So in case of a parallel to the given line, this part should be the same. This part should be the same, and only they differ by the constants. Otherwise, you are getting the coincident line. So now when the lines is perpendicular to the given line, what you observe that their coefficients are interchanged their places, and with middle sign will be the changed, because here you are getting the slope is minus a by b, here you are getting the slope is b by a. So that the product will be the what? Product will be the minus 1. So ax plus by plus c equal to 0. Just you interchange the coefficients, and just change the sign between them. Okay now. So 3 points, now 2 points will be on the same side or the opposite sides of a given line. This one is the given line, and you are taking the point will be either on the x1 y1, and here x2 y2 will be on the same side, or it may happen that this is the line and x1 y1 is here, x2 y2 is here. So either they will be on the same side or they will be on the different side. It is only possible you should put the value of the or substitute this coordinate of the points on the given equations, and calculate x1 plus by1 plus c, and calculate x2 plus by2 plus c. If they having the same sign, that means both the points are on the same side of the line. If they are in the opposite in sign, that means both the points are on the opposite side of the given line. 3 lines will be concurrent. What is the meaning of its concurrent? If the 3 lines passing through the same point, then the lines are known as the concurrent lines. So 3 lines will be the concurrent. It is only happened that the corresponding determinant should be the 0, and this is the necessary condition but not the sufficient condition. What is the meaning of it is not the sufficient condition? Because the value of the determinant 0 does not always implies that all the 3 lines are concurrent. Why? Because if the 2 lines are parallel or the 3 lines are parallel, then what will happen that the value of the determinant is 0, because the coefficients are in the proportional. So in that case determinant is 0, but the lines are not concurrent. So what I want to say that if the lines are concurrent, then it is confirmed that determinant is 0, but determinant is 0 does not always imply that the lines are concurrent. So be careful about it. When you are going to apply the determinant method, you should first check that lines are parallel or not. If they are not parallel, then you should apply this one. If the lines are parallel, don't go approach this method. You should find out the point of intersection of the first two, and try to satisfy it by the third line. Try to check whether the point is satisfied by the third line or not. Okay, now we are going to calculate the family of the lines. So 2 lines are given. One is the L1 line, another is the L2 line, and these lines are suppose intersecting line. They intersect at the point P. Now we are going to find out the family of all the lines through the point P. The equation will be L1 plus lambda, L2 is equal to 0. Lambda is the real number, but lambda if the lambda is the real number, and lambda cannot be equal to the minus 1, we don't take lambda is equal to minus 1, because what will happen, L1 minus L2, if they have the same coefficient, if you're taking the minus 1, then some constant will be equal to 0. Now in this family of the lines, you are getting all the member of this family except the L2. You never get the L2 line. So the most general way, so that your collection will contain L2 also is this one, lambda into L1 plus mu into L2 is equal to 0, because sometime if you are making this part is 0, L mu is not equal to 0, then you are getting L2 equal to 0. Now in some figure oriented problems are there. In the figure oriented problem, or some optical problems are there in the mathematics, where you do not consider you should not consider the modulus when you are going to calculate the angles between the two lines. Why? Because suppose you are going to calculate the angles between here. So now this is your first line, this is second line, this is third line. So now when you are taking the line, so you have to take in this way, slope of the 2 line, second line minus 1 line, then you have to calculate the slope of the third line minus second line. So and consider these angles are equal. So in this way we are taking the like that, second line, first line, and third line. The slope of the second line minus slope of the first line, you are getting some. That means when you subtract this one, you are getting the tan theta 2. So now going to calculate this theta. This is also theta. This is also theta. Both the theta are same. This is 2. This is 1. That is 3. So here we are applying the tan theta. That is m2 minus m1. We are taking without modulus sign, and then calculate the third one. So here we are taking the modulus. That is the m3 minus m2. We are taking the m3 minus m2 without modulus sign. Okay now, so in this way, since the angles are same in the problem of the optics problem, in case of the optics problem or some figure, the problem having the figure, so in that case we are going to calculate the angle between the two lines without the modular sign. So in that case we are taking the second line minus first line, the line which is on the right hand side, we take the slope of that line first. So slope of the second line minus first line is equal to the slope of the second line minus the slope of the third line minus the slope of the second line. Just like the AP we are doing, second term minus first term, third term minus second term. In this way, second slope minus first slope, then third slope minus second slope without the modular signs. Okay now. So this formula, this is the question number 15. Now we have to explain a lot of things about the 15. Okay now, then you can understand. So give me some time so that I can find out the theoretical part. Here, student, this is not actually the any formula, it is actually the part of it is actually the problems, and this is the result of the problems. So in optics, when I make the video on it, so there are some problems. So when you solve it, then you can come to know that the value, this value will be the maximum, and the maximum will be the AB. Here also you are getting the minimum value should be the AB. In the two different situations are there, you have to calculate the maximum and minimum value of this problem. So this is not actually the any formulas are there, depending upon the problem we will get these results. Now 16 was very important. There are two lines and you are going to calculate the perpendicular bisector of this line. Two lines are there, you are going to calculate the perpendicular bisectors. So now formula is a1x plus b1y plus c1 divided by root over a square plus b square plus is equal to plus minus a2x plus b2 plus c2 divided by root over a2 square plus b2 square. So both the lines having the equation a1x plus b1y plus c1 equal to 0, first line, and second line has the equation a2x plus b2y plus c2 is equal to 0. So their perpendicular is denoted by two perpendicular are there. If you get the one positive sign for the b1, and if you take first perpendicular and minus for the second perpendicular b2. Now bisector containing the origin, what is the meaning of it? Suppose this is the two lines, this is the two lines, and suppose your suppose this is the coordinate axis, and this is the what, two line intersecting. So this is your two lines are intersecting here. So you notice that these angle contains the origin actually. So this perpendicular bisector contains the origin. This perpendicular bisector of this angle will be container of this origin. Okay now, so here we are actually wanted to find out of b1 b2 which contains the origin. So first of all, to find out this one, we have this formula na, a1x plus b1y plus c1, which is the first line. Then you have a2x plus b2y plus c2, which is the second line. So first of all, make this c1 c2 are positive. After making c1 c2 is positive, write the equation of this line. This one we have to write after making the c1 c2 positive. Then if you choose the positive sign from here, this will give the bisector containing the origin. What I said, the process is a1x plus b1y plus c1 and a2x plus b2y plus c2 equal to 0. First you have to check the c1 and c2 both are positive or not. If they are not positive, by multiplying minus 1, make them positive. So our first duty is we should make the c1 c2 positive. Then we apply the formula for a1x plus b1 plus c1, where c1 is positive, and a2x plus b2y plus c2 is equal to 0, where c2 is positive. Our formula will be a1x plus b1y plus c1 divided by root over a1 square plus b1 square plus minus this. So among the two signs, if you choose the positive sign, then you will get getting the angle containing the origin. Gives the bisector angles the bisector that contains the origin. Method 2 is also there, find out. So here also you have to make the c1 c2 positive. After making the c1 c2 positive, then there will be changes in a1 a2 and b1 b2. Then you have to calculate the multiplication of a1 a2 into b1 b2. This quantity you have to find out whether it is positive or negative. If it is negative, then origin lies in the acute angle bisector. If it is negative, then the origin line is the acute angle bisector. If it is positive, let me check now. If this part is 0, lesser than 0, then the origin lies in acute angle bisector between the lines. When you choose the positive sign, that means there is positive negative sign is there. Here you can choose positive or negative sign. So positive sign, when you choose, this part is negative, and you are choosing the positive sign, then positive sign bisectors is actually the acute angle bisector. is actually the acute angle bisector. Now you are trying to find out which bisector is the acute angle bisector and which one is the obtuse angle bisector. So in this situation you have to first make C1 C2 positive. After making the C1 C2 positive, then you are going to find out A1 A2 plus B1 B2 value. Suppose that this value is positive or negative, whatever you will get. So suppose this value is negative, then you choose the positive line, positive sign for the bisector equation. Then you choose the positive sign from the bisector equation to indicate that you are getting the acute angle bisector. But here A1 A2 plus B1 B2 is negative, and you are also choosing the negative sign, then it will be the obtuse angle bisector. Obtuse angle, it should be here bisectors, obtuse angle bisector. Okay. Now third method is there to calculate the acute angle bisector and the obtuse angle bisector. You know the two lines are intersecting like that, and there is the bisector B1, this one. Suppose this is the line L1 and this is the line L2. So now I am going to calculate what is the value of this theta 1 between the L1 and B1. So first of all, pick any line L1 and B1. First we choose any line L1 and any bisector B1. Any line L1, any bisector B1, and calculate the tan theta between them, that means our target is, this is our L1 and this is the B1. So I am going to calculate the angle between them here. What is tan theta? This angle I am going to find out. And suppose after finding out I am getting tan theta is less than 1. That means what I am getting, the angle between the bisector and the line is less than 45 degree. So double of it is less than 90 degree. That means I am getting the acute angle bisector. If tan theta is positive, that means theta is more than 45 degree. So double of that theta is more than 90 degree. That means we are getting the obtuse angle bisector. Is it clear to you? Now suppose what I am saying, this is a line, this is a line, this is line L1 and this is the bisector B1. This is theta. You are going to calculate this value theta, and theta is more than 45 degree. So if it is more than 45 degree, so this angle is what? More than 90 degree. Because half part is more than 45 degree, this is 45 degree more than, this is also more than 45 degree, total angle is more than 90 degree. So this is the obtuse angle bisector. So according to the tan theta, you are also, this method is actually very comfortable method. Okay now, so in this method you choose any line, any bisector, you choose and find the angle between them. If the angle is less than 45 degree, then you are getting the acute angle bisector. If the angle is more than 45 degree, then you are getting the obtuse angle bisector. So now this bisectors concept is very important. Okay, so we now you summarize this concept again. To find the bisector of the two lines, you have to take the formula a1x plus b1 plus c divided by root over a1 square plus b1 square is equal to the plus minus sign a2x plus b2 plus c2 divided by root over a2 square plus b2 square. Now if you are going to calculate the angle bisector which contains the origin, for this reason you have to make the c1 c2 both are positive. After making them positive, then you will do write the equation bisector and write the equation of the bisector. Now in this case, if you choose the positive sign, then it will be the bisector which contains the origin. Now you are going to calculate the acute angle bisector, obtuse angle bisector. So in case of the acute angle bisector, you choose c1 c2 makes positive, then calculate the a1 b1 plus a2 b2, a1 a2 plus b1 b2. This quantity you have to calculate. This quantity, suppose you are getting less than 0, so in that case the positive sign gives the acute angle bisector and the negative sign of the bisector's formula give the obtuse angle bisector. If a1 a2 plus b1 b2 is positive, then the positive sign will give obtuse angle bisector and the negative sign will acute angle bisectors. Third method is there. You choose any perpendicular bisector and any straight line and calculate the angle between them. If the angle is less than 45 degree, then you are getting the acute angle bisector. If the angle is more than 45 degree, then you are getting the obtuse angle bisector. Now here is some shifting is there. So if you shift your origin from here to some point here whose coordinate is, suppose this is here from hk. So you are shifting your origin from 0 0 to hk, and it is the old coordinate xy and current coordinate x plus y. Okay now, current coordinate is x plus y. The old coordinate is equal to current coordinate plus the coordinate of the origin. Old coordinate is equal to the current coordinate plus here x and y, capital X capital Y is the current coordinate. Current coordinate means coordinates of the point with respect to the given coordinate system, new coordinate system, after the shifting the origin from the 0 0 to the h comma k. So old coordinate is equal to the current coordinate plus h. Okay now coming to the pair of straight line, we know that this is the homogeneous second degree equation. Homogeneous second degree equation. Why it is homogeneous and second degree equation? Here every term has the degree 2. so it is second degree. And homogeneous means there is no difference between their degree, so every term has the same and equal degree, and the value of the degree is 2 in all cases. That's why it is known as the homogeneous second degree equation. So every homogeneous second degree equation represents the pair of a straight line, pair of a straight line. So now suppose if you are going to calculate one line which is equal to y is equal to m1x, and here you are getting the another line y is equal to m2x, so therefore equation of the pair of line will be in this way, because you are writing in this way y minus m1x and then y minus m2x. So that is the way to write the joint equation. So it will be y square minus m1 plus m2 into x plus m1 m2 into x square. So this is the joint equation. Suppose if you are going to write the joint equation of x equal to minus y and x equal to y, so how can we write? You never multiply in this way x square equal to minus y square. This is the wrong way. So first of all you should convert into the standard form, x equal to minus y. So from here we can write x plus y equal to 0. Right hand side always be 0, x equal to y, then you should write here x minus y equal to 0, and the correct equation will be x plus y into x minus y. Okay, now you don't you have to write the this will be equal to 0. So now you should first write the equation in the standard form, so that the right hand side will be the origin, right hand side should be the 0, then after that you should multiply the left hand side, so you will get the standard equation or the joint equation. Line represented by the homogeneous second degree equation, this is our homogeneous second degree equation. From here we can find out, we can consider this equation as the quadratic equation of y, and the other variable I consider as the constant. Therefore y you are getting in this way. Okay, now so here after cancellations by 2 you are getting this quantity. So this will be the discriminant will be d, which is equal to h square minus ab, and here since it is the quadratic of y square, so you and having the two roots, or you can do one thing, from here you are, what we observe that they are considering their roots. Okay, one root they said m1, other roots they said m2. Okay, so that means they are considering m1 is minus h plus root over of h square minus ab by b, and here they are considering m2 is equal to minus h minus root over h square minus ab by b. So this equation, these roots they are considering as m1 m2, though sum of the root is there, product of the root is there, difference of the root is there. And the discriminant, what about the discriminant? This is the quadratic equation, and this known as the discriminant. If the discriminant is positive, the discriminant is greater than 0, we know that the roots are real and the unequal. So here the lines are real and the distinct. If discriminant equal to 0, then the roots are equal. That means here the lines are same, coincident line. If the discriminant is less than 0, then the lines are the imaginary, then the lines are the imaginary lines, then the lines are the imaginary lines. And here we have the second degree equation which represent the two line L2, L1 and L2. Now we are going to calculate the angle between them is tan theta, which will be equal to same as 2 root over h square minus ab divided by a plus b. The angle between the pair of lines is this one, tan theta is equal to 2 root over h square minus ab divided by a plus b. So here if the numerator is 0, that means h square equal to ab, then we have the parallel lines and coincident lines, or lines are coincident, pair of line passing through the origin, and this part is also 0, that means both the lines are same and coincident. So if this part is 0, then we say that the lines are perpendicular. Okay, now but if h is equal to 0 and m1 m2 0 and theta 1 theta 2 is equal to pi, if h is 0, m1 m2 is 0, h is 0, m1 plus m2 is also 0, h is 0, m1 m2 is 0, then we say that theta 1 plus theta 2, okay, their sum of the angle should be pi. Okay, and homogeneous equation of degree n will represent the n line passes through the origin. Okay, so now if we have the homogeneous equation of degree n, so there should be the n line they passing through the origin, there should be the m line they passing through the origin. Okay, now this is the theorem. Now ax square plus 2h square plus by square equal to 0. We are interested to find out the two lines they are giving. One is the L1, another is L2. Now what about the B1 and B2? Bisector 1 and bisector 2. The joint equation of the bisector 1 and bisector 2 is given by x square minus y square divided by xy. X square minus y square divided by xy is equal to a minus b by h, or this formula you can write in this way also. X square minus y square divided by a minus b is equal to y by h. Now this is the general second degree equation. This is the general second degree equation. This represents all the conic, circle, straight line, everything. So if now this determinant is 0, how can we remember this determinant? Handsome Kunda has been found going for cinema. By this shortcut way or by this method, by this poem, you can memorize this determinant value. A handsome Gunda has been found. A handsome Gunda has been found going for cinema. Using this, you can memorize this determinant. Now this is a general second degree equation, and this equation has L1 and L2 represent two line. When number one, this determinant should be 0, number one, and the angle between the two line is this one. Where theta is the angle between the line L1 and L2. Now we come to the next and the last part, that is called the homogenizations. That means suppose one curve is given, and this curve is actually given by this line. Okay, now by this second degree equation, this curve is we are obtaining, and there is the line which intersect. This line has the equation Lx plus My plus n. So this line intersect your curve at the 2 point. One is A and this point is the point B. So now we are going to calculate the equation of the line joining origin with A, origin with B. So we are interested to calculate the joint equation of OA and OB. That means this is the curve, this is the line given, and you are joining this one and you are joining this one. So this is OA and this is OB. So what will be the joint equation of OA and OB? So we have this equation, general second degree equation, and we do the homogenization. That means every time I should make the degree 2. So it is the degree 2, it is degree 2, it is degree 2, but it is degree 1. So I multiply by this term. That means from here I am taking Lx plus My is equal to minus n. So dividing by minus n both side, you are getting 1. So in the place of 1 I am writing as Lx plus My by n. Here I am writing Lx plus My by minus n. So here this part actually 2gx, x is here, one x is missing here, 2f, this should be the y only. There is also be one y. Now coming to the c, which is constant, so I have to take this quadratic part, because so that the every term should be having the degree 2. So this is known as the homogenizations. So you know that every homogeneous equation of degree 2, every homogeneous equation of degree 2 of the two variables x and y always represents the a pair of line passing through the origin. So this is our target. We convert the given equation into that form, ax square plus 2hxy plus by square equal to 0 in this format. That means every term should be the degree 2. So that means then in that case we are actually obtaining both the equations OA and OB. So if the curve is given and the line Lx plus My plus n intersect the curve with the 2 points, and you are joining the origin with that points OA and OB, and you are wanted to calculate the joint equation of the lines OA and OB, then this is the only way. Ax square plus by square plus 2hxy, then 2gx. In 2gx, the multiply this term is Lx plus My by minus n, 2fy, and multiply this term is Lx plus My minus n, and c constant is multiplied with Lx plus My by minus n whole square, because you know that Lx plus My by minus n is nothing but the 1. So multiplying by 1 by any term, there should be no change, the term will be the same. So in this way we are completing the formula part of the quadratic equation. In the next video I am going to discuss about the, I think, parabola. We should discuss the parabola, ellipse and hyperbola. In this way today my target is to upload all those conic sections sheets or formula. From tomorrow, after completion of these formula sheets, we are going to discuss the theory classes as well as the problem classes. So now don't forget to subscribe my channels and push the bell notification, so that you will be updated with the Maths Academy. And now I am very happy with you, and thanks for watching my channel. Now we will meet you again in the next video. Till then.